Okay, in this section here, we'll look at a simple thing, which is the hazard of using electricity. Okay, in this section here, we will cover three common hazards when we talk about using of electricity, okay, or dangers of using electricity, hazard of using. Okay, now, what the first one that we look at is damaged insulations. The second one we look at will be overheating of cables, and finally the dam condition. Okay, one thing to take note is other than knowing these three hazards, one of the main thing that students have to do is you must know how to elaborate or how to write your answers based on these hazards. For example, if you're looking at damaged installations, when you write your answers to the marker, you need to remember to write the keywords that you're looking for. So if you're looking at or you're describing overheating or you're explaining overheating of cables as a hazard, so you also must take note of what are the keywords that the markers are looking out for. So in the later process, okay, take note, other than understanding these three dangers, okay, these three hazards, students will also need to know the keywords used, okay, to describe or to explain these three hazards. Okay, because take note, if in exam, because of the way the marking is being done, okay, we look at the keywords. Okay, so the meaning behind the English, the way you write, people might actually misinterpret differently. So different marker may interpret your answer differently. But if we all uses the same keywords, okay, we can ensure ourselves that the answers that we write using the same keywords, the interpretation of the keywords by any markers will be very, very close to each other one. So it will be very, very close to the actual answers. So that's why if you look for exam purpose, the important thing is to actually to take note of the keywords, okay, to describe your answer. Now, for damage installations, okay, the common thing about damage installation, like the word suggests, is that the outer layer of the cable is worn over time. The insulating material is worn throughout. Okay, so that it could be just a simple like twisting, cracking, or like it could be just an old cable, like, where the rubber is being moldy, is solid, it cracked already. Okay, so and what does it do is when it crack, okay, when the cables or when the conducting cables crack or you have some fault in the cable, the exposed live wire, the live wire is being exposed. Okay, so one of the keywords that we look at for damage insulation is that students, in your answer to explain damage insulation, we tend to focus on the insulation being worn out, all these things. But what's so fantastic or what's so danger about insulation material worn out is because the live cable are being exposed. So this is what we mean by the keywords used in your explanation. So you have to use the word exposed live wire, okay, or live wire are being exposed. And as a result, what happened for exposed live cable, you have electrical shock or even or electrocution when you touch. So in between, so you look at the answer for damage insulation, the answer will be quite standard, whereby students most likely will talk about insulations, will talk about electrocution when touch, all these things. But what they often left out is the keywords exposed live wire, because exposed live wire is ultimately the hazard behind damage installations. Okay, it's more the main cause for electrocution is the exposed live wire. Okay, it's not because of insulating material worn out. Okay, so take note of the way you craft your answer. Now, so these are what I mean by exposed cable. Okay, but worn out insulating material. But important thing is that whereby the cables, even the line wires here are being exposed. So that's one of the danger that we are talking about. Okay. Now, the other hazard that we talk about is overheating of cables. One of the common example of overheating of cables, one of the main cause is actually this type of scenario, what we call the uses of multi-plug, or whereby you have multiple socket attached to the plug itself. Okay, so what's the problem with this? Is because when you have multiple socket drawing current from a single socket, what you're doing here is you're actually drawing high amount of current, okay, from the main conducting cable. For example, this. Okay, so let's say this is a power source. Okay, so this is the power source, which is maybe I'll just say it could be from the power socket. So because of power socket, there are multiple plugs being plugged in. For example, I have a plug to control my light, Maybe I have another wire connected to my power source. Okay, this could be my laptop. Okay. At the same time, maybe I could be charging my handphone. Okay, this could be my iPhone. And maybe at the same time, I also be connecting my printer, okay, to the same socket here. Now, so what's the problem here is that when you all the when four appliances are being switched on, okay. Now, what happens is this: when the four current are being switched on, they will draw their individual current. Okay, each of the appliances are working at the correct ampere, correct power. Okay, they are working normally. But what happens is your design of your power socket here, okay, originally when I designed this, it's not meant to support so many appliances, so many concurrent appliances drawing current at the same point. So you'll find that I have current 1, current 2, current 3, current 4 drawing current from where? From the main supply here, which is the I main. Okay, so which means the current I draw is actually larger than what I anticipated. Maybe when I built this socket, maybe my intention was only for 2 appliances to connect to this socket. Maybe I only planned 2 appliances, laptop and handphone. But what I did is I actually connected 4 or 5 appliances. And because of that, the current I draw from the main will be exceeding large. Okay, will be unusually large. And because of that, okay, you'll find that the current in this main cable, the main conducting wire, is actually very high. And also, what's the problem with this is that because when you have unusually high current, and when the cables inside is actually thin wires, okay, you'll find that thin wire high current is one recipe for hazard, because when you have thin wire, you'll find that the resistance in the cable is actually very high. Okay, so when you have high current, high resistance, the ultimate problem you will have a lot of heat being generated in the cable. And because of that, you will have heating in the cable, your cable will be higher than expected. And as a result, what happened? You will have fire occurring inside the socket, and you will have electrical fire. Okay, so that's one of the problems that we have. So if you look at the keywords here, you are looking for is unusually high current, where I need the location, which is the main cable. Okay, in the previous example that I mentioned before, in this picture here, remember the current in each of the appliances is actually their normal current. The exceeding high current, the large current, where does the large current come from? Is at the main cable here. Is at this main cable here. So in your answer, you, for this particular hazard, okay, you must make sure that you actually mention high current and the location, the main conducting cable. Okay, because that's where all the hazard will come in. Okay, common mistake that student make is actually they will actually write high current, but they actually pinpoint the high current at the appliances side. So they will say that instead of the main socket catching fire, they will say that the appliances, the laptop, the handphone, all this, they have unusually high current and they will catch fire, which is wrong. Okay, because in the overheating of cable, okay, where the high current actually only occur at the main cable here. Okay, that's one of the things that students need to remember and need to avoid. Okay, when they explain this particular section here. Okay, the third condition here we have will be damp condition, which is wet. Okay, the water. Okay, so it's a very common fault that we have. I would say it's common sense that every one of us, we will practice in toilets or where we shower. We actually avoid having electrical socket nearby. Okay, so you will not charge your handphone when you're having a shower in the bathtub, or you will not actually blow your hair when you're like maybe you're still in the bathtub enjoying your bath. Okay, why? Because water has low resistance. Okay, it's a good conductor of electricity. It has very low resistance, and because resistance is low, okay, remember in chapter 16 or 15, when we talk about characteristics of Vi and R, resistance and current, they have a unique relationship whereby they are inversely, which means the lower the resistance, the higher the current. Okay, the less I resist, the more current will flow through. So because water has low resistance, so what it does now is that high current, it allows high current to pass through. So what happens is, imagine that you are blowing your hair, your hair dryer, and the hair dryer drop inside the bathtub, and you actually move in, you actually plunge your hand into the water to retrieve the hairdryer. And that is a no-no. It's a big thing. No. Because why? Because when the hairdryer is in the water, okay, the water being a low resistance medium, it will actually entice the large current to flow out from the main socket. Which means at this moment in time when the hairdryer is in the water, a large current will be flowing in the circuit, and if you reach out and you touch it, okay, you will get electrocuted. And even if you don't touch it, let's say, you'll find that the high current actually will produce a lot of heat, and there's a chances of what we call you have an electrical fire breaking out in your home. Okay, so this is one of the common hazards that you have in using your electricity. It's quite a common one, and the keywords for them condition, remember, is to take note is the mention of low resistance. Remember the keywords, and of course you have to mention high current. Okay, until now we have covered like 3 common causes, danger of electricity, 3 hazards, and when you write, okay, students, you other than understanding the concept behind it, the reason behind it, why these 3 factors are hazards, you also need to remember the keywords need to use when you to present your answers. So here I will do a summary of it, and there are things like keywords that you need to take note when you talk about the 3 hazards. Okay, of course the 3 hazards, it comes in various forms, depends on the questions, but most of the time the keywords actually revolve around like maybe high current. Okay, so it depends on where you are. So some high current, look at your electricity, you may have electrocution, or you may have thermal energy or electrical fire. Okay, so you look at high current, which is one of the common keyword. And if you look at water, like I mentioned before, you have keywords like what? Low resistance. Okay, if you have exposed cable, so damaged insulations, the common thing that we look at is exposed live wire. Okay, so these are the keywords that you need to remember to use when you write your answers. But these are the keywords that I actually encourage students to write, because these keywords they have the general common understanding among markers, that we will actually know that what the students are actually referring to, what the students are trying to tell the marker. Okay, so if you try to use other words, yes, you are allowed to use other words, but just that you have to make sure that your answers using your own words actually portray the correct meaning when it's being read by the marker. Okay, if the marker infer different meaning, okay, your answers will be wrong already, so you will not be able to get the marks that you require. Okay, so first thing for in terms of this topic is understand the concept, followed by the keywords that you need inside this particular topic here. Okay, the next section we look at, okay, will be on the safety feature, but that will be a topic for the next video here. If not, it will be very, very lengthy. Okay, if not, okay, I will end here for this particular section for the hazards. Okay, anything, just let me know in the comment bar. Okay, if you're not, okay, remember to subscribe to my channel to get the latest update for the video or the topics that we are going through, preparations video that I send out for you guys. Okay, if not, thank you very much. Yeah, have a great day.